Hello everyone. In this part of video I am going to discuss about porosity of cement, and this discussion is just to give you the glimpse of the course. So let us start the discussion. So porosity of cement paste. So first, what is porosity? Porosity is nothing but, with reference to cement paste, we can define it as volume of pores divided by volume of total cement paste. Now to understand this whole discussion, we should only understand the these two terms only, that what is the phases in the total volume of cement paste. For understanding total volume of cement paste, we should draw the schematic diagram of the for the phases of cement paste. Let us consider that we have taken C grams of cement to react with W gram of water. This is before hydration. Now after hydration, say for some degree of hydration H, the product which are formed are, some cement will remain unhydrated, so that is unhydrated cement. Some solid products will be formed, that is solid hydrated products, and there will be water in the three forms: gel water, capillary water, and the remaining space is nothing but empty capillary voids. In the whole discussion, we are going to refer this diagram again and again. This situation is after hydration. Now to calculate different porosities, that is gel porosity, capillary porosity, and total porosity of cement paste, we should understand what are the volume of these different phases. Before this, calculating the volumes of these phases, we should understand what are these, what is solid hydrated products, what is capillary water, what is gel water. So first is solid products, solid hydrated products. These are nothing but CSH, CaOH twice, calcium hydroxide, calcium silicate hydrates, or any other solid hydrated products formed in the cement are the solid hydrated products. The specific gravity for these solid hydrated product is generally taken as 2.5 gram per cc. Now we can see here that the specific gravity is between 1 and 3.15. The 1 is the specific gravity for water and the 3.15 is for cement. So the product must have the specific gravity in between them. Now the second product is unhydrated cement. The cement which could not get reacted during hydration is unhydrated cement. Later we will calculate volume for this also. The third is the water. Water can be in the cement paste in following three forms. First is chemically combined water, as we see in the schematic diagram. Chemically combined water, this is the water which is chemically bound to the molecules of the solid hydrated products. This water cannot be evaporated, as we know that this water is chemically bound and chemical bonds are strong in nature, so cannot be evaporated this water. And one thing, from experiments we have found that the volume of this type of water is 23% of cement weight, dry cement weight. So as we have taken C grams of cement. So gel water volume will be 1.23 C. Now the second time is gel water. What is gel water? First is chemical water, which is chemically bound. Second is gel water, which is the water which is adsorbed on the surface of solid hydrated products. The water gets adsorbed due to the polar nature of water molecules. As we can see, some delta plus will be here and some delta negative will be here. Some polar nature will be there. Due to this polar nature only, water gets absorbed on the surface of solid hydrated products, and this is found that the porosity of gel water is 28%. This is also from experiments, results of various experiments. Now the third is capillary water. Capillary water is the water which is remaining excluding the above two water. The water molecules of this capillary water have larger size relatively. So here we can have one note that the gel water and the capillary water can be evaporated, whereas the chemically compound water could not be, because it is bounded by strong forces. Fourth phase is, as we have seen in the schematic diagram, empty capillary spaces. I can show you this in the diagram. The first was the solid hydrated products, gel pores, capillary water. This is unhydrated cement, and the remaining part is empty capillary. So after calculating all volumes, some volume is still less than the original volume, which is nothing but the volume of empty capillary spaces. Now we should start discussing how to calculate volume of these phases. First is the solid products, hydrated products. Let us say it is Vp. So we saw in the chemically compound water that the 1 gram of cement reacts with 0.23 gram of water, and so it will form 1.23 gram of hydrated products. So if we have taken C gram of cement and we have considered H degree of hydration, so CH gram cement will result into 1.23 CH grams of solid hydrated product. Specific gravity we have already seen, 2.51 gram per cc or without unit. So from here, volume of solid products, say Vp, is nothing but 1.23 Ch upon 2.51 Cc. This is the first volume which we have calculated. Second, we can calculate volume of empty capillaries. So as we have seen that the empty capillaries are generated because of the difference in the volume of original products and the volume of the final product. So we can calculate this difference. Original total volume is nothing but the volume of cement and the volume of water. We have taken C grams of cement, that is C divided by specific gravity of cement, C 0.15. This is the volume of cement, and W. Force, C H degree of hydration and considering chemically combined water, it will be like 1.23 CH upon 3.15. This cement only will hydrate plus 0.23 CH, sorry, CH divided by 3.15 plus 0.23 CH. This cement is getting in the hydration process, so divide by its density. Final volume of solid hydrated products we already calculated, that it came out to be 0.149 CH, which we have written like 1.23 CH upon 2.51. This is nothing but this 0.49 CH. So, V1 V2 difference is V2 minus V1, so it will come out to be 0.06 CH. This is nothing but the volume of empty capillaries. One phase also we have seen unhydrated cement. It is easy to calculate its volume. We have seen that the CH gram of cement had already hydrated, so the remaining cement is only the unhydrated cement, which will be nothing but the C minus CH. C is the original, CH is the hydrated. Now divide by density of specific gravity of cement 3.15, this will be the volume of unhydrated cement. Simple. Now next is the gel pores. We have already discussed that the volume of gel pores are 28% by volume of total cement gel. So 28% can be written as volume of gel divided by volume of gel plus volume of solid hydrated products VP. VP we have already calculated, which came out to be 0.49 CH. So only unknown is Vg. Vg upon Vg plus 0.49 CH is 0.28. From here we can calculate volume of gel pores, which will come out to be 0.19 CH. So up to now we have seen three volume calculations. First is the volume of solid products, which came out to be 0.49 CH. Second, we have seen volume of empty capillaries, which came out to be 0.06 CH. Third, we seen volume of unhydrated cement, which was 0.23 CH 1 minus H. Now the fourth also we calculated volume of gel pores, which came out to be 0.49 CH. Now the remaining volume of capillary water, only phase is remaining volume of capillary water. This can be calculated by volume conservation. Total initial volume is equal to final volume. So initial volume we know C gram of cement, so C divided by 3.15, this will be the volume of cement, plus W specific gravity 1, so this will be the volume of water, equal to final products. Final products we have seen, first is the say solid products, then we have seen empty capillary, which is we have denoted as VCE, plus we have seen gel water plus some unhydrated cement plus capillary water. So from here we can calculate this one, because all these four volumes we have already calculated. Once again we can refer to the schematic diagram. Here we can see that the C divided by 3.15 plus W. This will be the original volume and the final volume must be equal. So, Vp, this one, this is Vce second term, and the third term Vg will be gel pores, fourth is the unhydrated cement, this one, and the remaining is the capillary water, which we have to calculate. All these volumes which I have written here we have already calculated. So, we can from this equation easily calculate the volume of capillary water. C 3.15 plus W divided by 0.49 Ch, this was 0.06 Ch, Vg came out to be 0.19 Ch and 0.19 Ch, then the unhydrated which will came out to be C1 minus H, and the remaining is V of W, capillary water volume. From here we calculate we can calculate the volume of capillary water, which will come out to be W minus 0.42 Ch. So, up to here we have calculated all the volumes of these phases. We have calculated volume of unhydrated cement, then the next is volume of solid hydration product, we have calculated gel pores volume, we have known capillary water and the empty capillary spaces. All these volumes we have calculated. We know the original volume, what is the volume of cement, what is the volume of water, and the degree of hydration. This whole discussion is taking place for the degree of hydration H. Now comes the porosity part. For porosity now we will just have to put these different type of volumes in the formula of porosity. So, first let us say porosity of capillary pores. Say Pg. So, Pg will be nothing but the volume of capillary pores, total capillary pores divided by total volume of cement paste. Now, we will just have to put these values. Capillary pores will be the sum of these two, capillary water VCW and the empty capillary VCE. We have already calculated this. So, VCW plus VCE divided by total volume will be nothing but, as we have already calculated, C divided by 3.15 cement volume plus water. These two terms we can put, VCW is W minus 0.42 Ch and the VCE is 0.06 Ch divided by C 3.15 plus W. After solving this mathematical equation, we will get the final form will be like W by C, W minus 0.36 Ch upon C divided by 3.15 plus W. We can write this in the form of W by C, which is important for cement, as the all other things are related with W by C only. So, divide by C and multiply by C, W by C 0.36 H, this is C, and 1 by 3.15 will become 1.317 plus W by C. So, this came out to be formula for calculating capillary porosity of the cement paste. Now, second we can discuss is gel porosity. Pg, it will be nothing but the volume of gel pores divided by the total volume of cement paste. Volume of gel pores divided by total volume. Vg we have already calculated. For your information, I again show you this 0.19 Ch Vg came out to be this much 0.19 Ch. Total volume is again same, C divided by 3.15 plus W. Now the final form can be written as 0.19 Ch divided by 0.317 plus W by C in the form of W by C. This is nothing but the formula for gel porosity. Now the third porosity is porosity, total porosity of cement paste. We can calculate PT in two ways, total pores divided by total volume, or we can write it as PT equal to nothing but capillary porosity PC plus gel porosity PG. It will be sum of two. These two we have already calculated. So the summation will be total porosity, which will come out to be W by C minus 0.7 H divided by 0.317 plus W by C PT. From both the two conditions we can calculate it. So we have calculated all three types of porosity, and that is gel porosity, capillary porosity and the total porosity. So now after porosity I will also like to discuss one small topic, which is maximum degree of hydration, which is related to porosity only. Maximum degree of hydration. So we have discussed that when the W gram of water and C gram of cement reacts, these are the products which will be formed. These are the capillary water, capillary spaces. So in this capillary space only, here the hydrated products are already formed and some unhydrated cement is there. In this space only, when the lateral hydration proceeds, the products, the further hydrated products are formed in this volume only, capillary pores. So if we increase degree of hydration, that is say we are increasing time, and with increase hydration will increase. So capillary porosity will decrease, because the products will be formed in capillary porosity and pores will be reduced. So capillary porosity will reduce. Now we want to maximize degree of hydration, which we have denoted as H. So for this H maximum, capillary porosity should be minimum, say 0. We will try to make capillary pores 0 for maximum hydration. So PC equal to 0. Now we have seen the formula for PC. It was W by C minus 0.36 Ch divided by 0.317 plus W by C is equal to 0. From this we can calculate W by C minus 0.316 Ch is equal to 0, and it will say H max is equal to W by C divided by 0.36. It is not C here, sorry. So this will be the maximum hydration to which the hydration process can take place. Divide the W by C ratio with 0.36, we will get the maximum degree of hydration. This is the whole discussion. More discussion you will see in lecture series. So please see the videos. Thank you.